Hello friends, our today's topic is a solenoid magnetic field due to a current in a solenoid. When current passes through the solenoid, magnetism is produced. So this is the magnetic effect of electric current. Let's see what is the solenoid. A coil of many circular turns of insulated copper wire wrapped closely in a shape of cylinder is called as a solenoid. It is very easy to make a solenoid. Take a insulated copper wire and wrap this insulated copper wire in many turns in the form of cylindrical shape. So solenoid will be formed. So what is the difference between magnetism produced in the solenoid and magnetism produced in the bar magnet? This is very important. Magnetism produced in the solenoid. Solenoid is a cylindrical shape of number of turns of insulated copper wire. It looks like a spring. So this is the solenoid. It is connected with the source of electric current, that is battery. So when current passes through the solenoid, it produces magnetism. Magnetic field produced around the solenoid. So it acts like a bar magnet. It shows the similar properties like the bar magnet. That is, it has south and north pole. It produces magnetic lines around the magnet. So when current passes through the solenoid, it produces magnetic field. Now, if we look at the solenoid from A is south pole. So if we look at the solenoid from A, we observe that the current flow in clockwise direction, implying that this face is acting like a south pole. So this is the south pole of the magnet. So when current passes from side A to B. So if we look at the solenoid from A, we observe that the current flow in clockwise direction, implying that this face is acting like a south pole. If we look at the solenoid from B, we observe that the current flowing in anti-clockwise direction, implying that this face is acting like a north pole. So these are the two poles of solenoid. When current passes through this solenoid, it produces magnetism, it produces magnetic field. So it has also two poles like a bar magnet, and they act like a south and north pole when electric current passes through the solenoid. When we compare the pattern of the field with a magnetic field around a bar magnet, they are similar. See this? The pattern of magnetic field is the same like a bar magnet. So this is the first similarity, that is, the pattern of magnetic field is similar like pattern of magnetic field of bar magnet. One end of the solenoid behave as a magnetic north pole, while the other end behaves like a south pole. It is a similar like a bar magnet. So one end of the solenoid behaves like a north pole and other end of the solenoid behaves like south pole. The field lines inside the solenoid are in the form of a parallel straight line. They are almost parallel to each other inside the solenoid. So these magnetic field lines are almost parallel, and the direction of the magnetic field lines inside the solenoid is from south to north. Inside the solenoid, the direction of magnetic field is from south to north, and these magnetic field lines are almost parallel to each other. Outside the solenoid, these magnetic field lines similar like the magnetic field lines produced by bar magnet, and their direction is from north pole to south pole. This is another similarity, but most important is the lines passes through the solenoid. Inside the solenoid, these are parallel straight lines. This indicates that the magnetic field is the same at all points inside the solenoid. The field is uniform inside the solenoid. But for a bar magnet, the magnetic field is not same at all points. This is the first difference of magnetic field or magnetism produced in the solenoid and magnetism produced in the bar magnet. That is, at all points inside the solenoid, the magnetic field is uniform. A strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron. When placed inside the coil, it converts into the permanent magnet. So strong magnetic field produced inside a solenoid because magnetism at all points is the same. Uniform magnetic field lines. Due to this, it produces strong magnetic field and it is used to make a permanent magnet. Like a soft iron material is used to make permanent magnet by using solenoid. The magnet form is called as the electromagnet. So this type of the magnet or magnetism produced by a solenoid by using electric current, it is known as electromagnet. What type of factors affect on magnetic fields? Factors on which the magnitude of magnetic field depends. Strength of the magnet or magnitude of the magnet is depend upon different factors. These are magnitude of current. Strength of magnetic field is directly proportional to the magnitude of the current passing through solenoid. Strength of the electric current increase, magnetism increase. Current decrease, magnetism decrease. So this magnitude of the magnet is directly proportional to the current passing through the solenoid. If current increase, magnitude increase, current decrease, magnitude decrease. That is B is directly proportional to I. Second, number of turns per unit length of solenoid. The coil is made up from the insulated copper wire and there are number of turns. So number of turns are also affect or number of turns are very important for the magnitude of the magnet produced by solenoid. Strength of magnetic field is directly proportional to the number of turns per unit length of the solenoid. If turns increase, magnetic field increase. Turns decrease, magnetic field decrease. So it is also directly proportional to the number of turns per unit length of the solenoid. It means closely packed solenoid will have strong magnetic field as compared to loosely packed solenoid of the same length of the current. Number of turns, it is very important, and if these turns are closely packed, so then magnetic field is very strong. If these turns are loosely packed, the magnetic field is weak. So number of turns, these are closely packed or loosely packed, and the current passing through the solenoid, the effect on the magnetic field produced by solenoid. These are the two factors effect on the magnetic field. If current increase, magnetic field increase. Number of turns increase, magnetic field increase. Number of turns and these turns are closely packed. then magnetic field increase. This turns loosely packed, this magnetic field decrease. Has the same length and the current. Current is same, length of the insulated copper wire is same, but these turns are also important to produce magnetic field. It may be strong or weak. It is depend upon they may be closely packed or loosely packed.